Good morning, student. How are you? Hope you are staying safe at home. Remember the topic we had in the last one, where we talked about basic electricity? Well, now we're going to continue with the same basic electricity, but different topics. So now let's see objectives I have for you today, which are to describe electrical quantities, to state Ohm's law, and as well to solve some calculations involving electricity. So look at electrical quantities. There are three electrical quantities we have. We have the current, the voltage, and the resistance. But if you look at the first one we have here, current, it's just the flow of electrons in a circuit that bring about the heating effect of sound, heat, and light. And then you know that the unit of current is ampere, and it is measured with an instrument called ammeter. For the voltage, another electrical quantity we have is voltage. Voltage is the force that drives current in a circuit. It's also referred to as EMF, which means electromotive force or potential difference. In some textbook, it is written as potential difference, or EMF, which is electromotive force. And the unit is measured in volts. And it's also measured by an instrument called voltmeter. Another electrical quantities I have for you is resistance. Is the opposition to the flow of current and by the device connected to the circuit. Sometimes it could be carbon, sometimes it could be devices such as TVs, radios, and some electronic devices that we use at home. The unit of resistance is ohm and is measured by an instrument called ohmmeter. So in the next slide, we're going to see these are the electrical meters we are talking about. If you look at voltage, it is being measured by an instrument called voltmeter, while the current is being measured by this instrument called ammeter. You can see the calibrations on all of them, the calibration from 0 to 30, and in the ammeter we have the calibration from 0 to 0.2 ohm, 0.2 amp, for 0.68 to 1 amp. So in our next slide, we're going to define Ohm's law. Remember, John Simon Ohm was the one who worked in the field of electricity and who discovered this electrical quantity called resistance. And simply state that the current flowing in any metallic conductor is directly proportional to the voltage applied or potential difference, provided temperature and pressure and other physical conditions are kept constant. You can see from the relation that this is what the abbreviation of Ohm's law, that current, which is denoted by a symbol I, equals to voltage, which is denoted by the symbol V, over the resistance, which is denoted by the symbol I. So in another abbreviations, we're going to see how those ones are related. If you look at so you can make any of these parameters as object of the subject of the formula. So you can see that if you use voltage, if we are asked to measure voltage, the voltage equals to current times R, which is current times resistance. In this one too, you can also make resistance subject of formula in this abbreviation, that resistance equals to voltage over current. Remember, I told you earlier that the formula for voltage is denoted by the voltage is denoted by the symbol V, while current is denoted by the symbol I. Now let's look at this question I have for you today. We are going to consider this question. A potential difference PD of 24 volts is applied to a lamp of 48 ohms. Now we have to find what current will flow in the circuit. Now look at this quickly. How to solve this question of this kind? First of all, write the parameters. We're given that the PD, the first question 1, is given as 24 volts, while the resistance is given as 48 ohms. Now, to solve this question, remember that from this relation, from this relation, I told you about Now, current equals to voltage over resistance. Well, in that question, we're given the resistance and we're also given the voltage. So we have to find the current. So we're going to use this formula to calculate current. So let's look at the question. So from the relation, you can write the formula out first. Current equals to voltage over resistance. So we're given as PD, which is voltage. PD, potential difference, is also referred to as voltage, equals to 24 over, which is resistance. Resistance is given at 48. So you can have, so you can see, if you, 24 here, 1, 24 and 48, we have 2. So if you divide 1 by 2, you can write your answer as 0.5 amp, or we leave it as 1 over 2 amp. Simple. So in our second question, we're given that a current of 6 amp flows in a circuit when a PD of 24 volts is applied to it. We're asked to determine the resistance. Now, if you look at this question, you can see that we're asked to find the resistance. You go back to our formula, you can see which of the formula can we use. You can see we're given the voltage and we're given the current. So we'll use this formula to find our resistance. Resistance equals to voltage over current. So let's go to the question. Question 2. Question 2. We're given at the voltage equals to, our voltage is 24 volts and our current is 6, which is 24 volts, and our current is 6 amp. So what do we do? Using the formula I've told you about, we have resistance equals to voltage over current. So what do we have? Our voltage is 24. 24 over current is 6. So if you divide 6, if you divide 4 by 6, you're going to have 4 whole. Simple. So there are some questions I'm going to give you in the Google Classroom, which we're going to solve using all these parameters above to solve them. So if you have any question bordering on this, you can just communicate to me on the Google Classroom so that I can do more justice to it. Thank you. God bless you.